What's up, guys? Welcome back to another video. Um, I'm sorry I missed yesterday completely. Um, Not just like the Lico streak, but I just didn't record yesterday's because I was away for like the whole day, and also I just felt like I don't know. Yeah, I was just out the whole day, and I could have done it later, but I just wanted to sleep a bit early, um, earlier than usual. I'm gonna try to aim to sleep before like 3 for the next few days until school starts because I mean, as you can see, it's already midnight, past midnight. But in the other videos, I was doing work sometimes at like 2, 3, 4 a.m. And I feel like my brain just wasn't working during those times. So I'm gonna try to get better on that, which I already said I was going to. But I want to start even earlier than that, like 12 p.m. But the issue is that I've been waking up at like 12 p.m. So I really need to be waking up earlier and starting earlier. So that's what I'm gonna aim for. And I actually go back to school on the first, um, because I have to do RA training before like school actually starts. But I'm gonna be going back to my dorm and um, yeah. I mean, hopefully we'll be able to do a lot there, but um, let's get started with this. I wanted to start with C++ first. Oh, and updates. I think I'll just be leak coding until like I want to start leak coding instead of sharing my projects and stuff because um, I guess the main thing I want to do is leak code, right? Because I just was very inconsistent, and this has definitely been working, but I want to do even more. I want to aim to do around like 2.5 hours of leak code a day, whereas so far I've only been doing like 1 to 2 hours. So I want to step it up, um, and I'll just be focusing on leak code instead of my personal projects and stuff. But I will be just sharing like anything I'm learning rather than like stuff I'm working on. So let's get started with learning C++ because I kind of know C, but I don't know C++, and I want to get good at it before my internship in the summer, which requires C++. So I really do want to work on a new personal project, but I think, see, this is where I think I'm gonna have to do more with my videos, like lead code, learn C++, and learn like ML, and then I'll do like my personal projects aside. But yeah, and let's get started. I'm gonna go ahead and charge my Mac. Also, I just wanted to start with this because I wanted to eat some stuff first because I'm kind of hungry. But here's some fish. It's a Chinese snack. It's like really spicy minnows, I believe, but they're really good. And I have a pack of seaweed. Super Asian. Actually, I'm gonna try both at once. This is a lot of reading. See, this is my issue. I need more sleep before I code. October 17th, pretty recently. I might skip some of this like earlier stuff because I know it.
I'm gonna get one more.
That was pretty delicious.
Sorry, I'm just afraid that I'd drop like a piece on my shirt and then it would stain. Seems like I'm safe so far.
This is pretty interesting. A bug. Where's the short circuit in the hardware? I know all this stuff. Damn, that's just spicy.
Forgot what these like things mean. What does yellow mean? Okay, no. Rule, best practice, and warning. I'm not gonna do that. I'm just call this learn. Fuck.
I'm just gonna leave it. What the? I should probably. Okay. Okay. Seems like everything's working. That's good. Do they have jump in C++? Okay. And this. Preprocessors, IO stream, standard C out. Okay, I know all these. Okay. Okay, I think I'm just gonna go ahead and do the leak code for today. Can I just close this? See. Okay, yeah. So we're doing copy list with random pointer. If you read through it, so essentially we just want to deep copy it. Oh, I don't need to define the type. No, I do, right? Do you need to declare it? I don't remember. No, you don't. But how could I remember? How could I forget? Let's do head 2 equals node head dot head dot next head dot random. Oh, okay. Temp equals. I should just do this. No. Okay. Huh. I'm gonna do here. I'm just gonna do cur equals cur dot next to avoid deep copying the head again, and then I'll do a node with cur dot now cur dot next cur dot. And then I'll set I'll set like cur 2 cur 2 dot next. Turn head 2 at the end. What the fuck? Random pointer of node with label 13 points to a node. Temp. I started making a new node by constructing the curve. So initialize critical to head. I make a new head. Set critical to curve to next. Then cur2 equals the new head. While cur temp is a new node with the cur value. Set cur2 dot next equal to temp. Maybe I just don't know how to deep copy, and I'm just gonna do 4.0 for this. Oh, I see, the random pointers. So the random pointers are still pointing to the original list. Huh? Okay. Low-key don't know how to do it because... Do we have to do one pass where we initialize a deep copy? But then how do we get the... Because wouldn't the next pointer also be null? Or wouldn't the next pointer also be not deep copied? String. Int. Which one is int? This is an int. Oh, cur.val. Oh. Alright, I'm just gonna go ahead and watch the solution because I have no idea. No clue.
Hey everyone, welcome back and let's write. Hey everyone, welcome back and let's write some more neat code today. So today let's solve copy list with a random pointer. So we're given a linked list, and so this is a pretty big.
Oh, I did think about 2 passes. A hash map.
Description of the problem, but it's actually more simple than that. So basically, you can see down in the example, this is what you should pay attention to. We have a pretty ordinary linked list, right? So this is a node, and you can see each node has a next pointer, right? So it just keeps going. It's singly linked list for the most part, right? And then we get to the end, right? So this is the end of the list. This is the start. The only difference between this and a regular linked list is that every single node has one extra pointer. It has a random pointer. So you can see that the first node has a random pointer going all the way to null, right? You can see that the second node has a random pointer going all the way back to the first node. You can see the third node has a random pointer going all the way to the last node. So basically what the deal is that every single node has a random pointer, and that pointer could be pointing anywhere, right? It could be at null. It could be at some random node inside of the list. It could be at any of those nodes. So it has a random pointer, but it also has a next pointer, which is, as you would expect, just pointing at the next node. All we really need to do with this linked list is create a copy of it. By that, they mean a deep copy. So really what we're doing is for every single node, we're allocating new memory. We're actually creating a new node, right? And so you can see we have 5 nodes in the input, so we're gonna have to create 5 nodes in the output, right? So that's pretty straightforward, right? The only difficulty comes though is from the random pointer, right? Clearly these nodes are gonna be linked together, right, in linear fashion, but we also have random pointers, right? So for this node, we would have to create a random pointer pointing at null, right, which is pretty easy. That's what was happening with the first node. But for the second node, right, we'd have a random pointer going back to
How can we use a hash map? So first pass we create all the nodes. Makes sense. We then run through and okay.
the first node. And for the third node, we'd have a random pointer going to the last node. So it's not too bad, right? The only difficulty though with these random pointers is that, take the third node for example, right? Let's say we start cloning the node, right? We create a clone of the first node, then we create a clone of the second node, then we create a clone of the third node, and you know, the random pointers, this one's gonna be at null, this one's gonna point back at the first node, but the third node, right? We know its random pointer is going to be at the 5th node, but we haven't created a deep copy of the 5th node yet. So how can we assign a random pointer before it's even been created? Well, the answer is we're gonna do 2 passes. We're gonna have 2 loops, and so with these 2 passes, what the first pass is going to do is we're simply gonna take each of these input nodes, right, and we're gonna create a deep copy of the nodes, right? That's all we're doing. We're just gonna create copies of these nodes. We're not even gonna link them yet. Right, so that's what the first pass is gonna
what? We didn't even link them.
do. And in addition, the first pass is also going to create a hash map where we map the original node to the new node, right? So we're going to map every old node to the new copy. We're going to do that with a hash map, and this is going to take place. In addition, the first pass is also going to create a hash map where we map the original node to the new node, right? So we're going to map every old node to the new copy. We're going to do that with a hash map, and this is going to take place in the first pass. And in the actual second pass is where we're going to actually do all the pointer connecting. So we know that every node is going to have, you know, pointers to the next node. They're also going to have some random pointers as well, right? Like this is going to have a random pointer to the last node. And we're going to leverage our hash map that we create in the first pass, right? That we create using the first pass of our algorithm. We're going to leverage that hash map to map every old node to the new node. So for example, we see in the original third node, its random pointer is pointing at the original 5th node, right? We can leverage that by using our hash map. We can say, okay, in the copy of the third node, we want it to point to the copy copy of the 5th node, right? And we can use our hash map to get the copy. And so if this doesn't make sense yet, this is just a basic illustration. This problem is actually straightforward enough with the code that I think even if this doesn't make sense, when I show you the code, it'll make a lot more sense, because at the base, this is a 2-pass algorithm where we create a hash map and can easily solve this problem in linear time, because each pass is going to be iterating through the entire linked list. And our hash map is also going to take linear memory, O of n memory, because we are having to store every single node inside of our hash map. So with that being said, let me show you the code. It's actually easier than you might think. So remember, we are going to have a hash map. I'm going to call it old to copy, because we're going to be mapping every single old node to the copy of that node that we create. So first, we're going to iterate through the linked list once, right? So we're going to have a current pointer pointing at the head. We're basically going to keep going until this current pointer reaches the end of the linked list, aka when the current node ends, right? So we're going to have a current pointer pointing at the head. We're basically going to keep going until this current pointer reaches the end of the linked list, aka when the current node becomes null. So the first thing we want to do is create a copy of this node, right? So we can do that with the node constructor, and we're going to pass in the value of current. So current.value, we're creating a clone of the node, a deep copy of the node, putting it in copy. And now we're going to take this copy and put it in our hash map. So in our hash map, old to copy, we're going to map the old node to the copy that we just created, right? This is and put it in our hash map. So in our hash map, old to copy, we're going to map the old node to the copy that we just created, right? This is pretty the old node to the copy that we just created, right? This is pretty straightforward, right? We're using a hash map, mapping the old node to the copy node. And next, all we really need to do is update our current pointer until it reaches null, and then the first pass of our loop is going to be done, right? So remember, we're doing 2 passes. This is the first pass. All we're doing is...
Where's the old? So this is the hash map. Initializing the head, while current copy looks... Okay, but what is old?
Cloning the linked list nodes and adding it to the hash map. We're not connecting the pointers yet. That's what this loop is going to be for. We're going to run the loop one more time, setting current to the beginning of the linked list, keep going until we reach the end of the linked list. Now we're going to set the pointers. So we're at the first node, let's say, of our linked list, right? That's what current is. So let's get the copy of the node. Remember, we already created the copy in our hash map. So old to copy, we use current, and this gives us...
Oh, as in the current.
the copy node of current, right? And now what we want to do is for this current node, we just want to set its pointers. Because remember, we are required to set the pointers to create a full deep copy of the linked list. We need to set the next pointer, right? So copy.next, we have to set that pointer. We also have to set copy.random. So copy has 2 pointers, and we need to find those.
So then we do it at old to copy at the cur.next
nodes, right? So copy.next. How do we get copy.next? Well, we know we have a map that can map original nodes to the copies, right? So if we take current.next, that's going to map us
to
the copy of current.next that we created.
Nice.
And that copy can be stored in copy.
That makes sense. Oh my goodness. That's so smart. Okay. Hash map at cur equals copy cur equals cur. So that created all the copies, and then cur equals head cur hash map at cur, and copy dot next is set to hash map at copy dot next then copy dot random equals hash map of copy dot random. Okay, and then we return hash map at head, which would give us the head of the new list. Fuck. Oh. Here, none. What?
Copy.next, right? Created a copy.next. We'd want it. So it's pretty straightforward, right? If we have our initializing of the hash map, I'm just gonna add one
Oh.
value. Null is gonna map to null. So it's pretty straightforward, right? If we had a old node that was
I see. So that would fix our error, I think. Vibe. Oh. Okay, I know it's... Oh my. That was actually a lot... That made a lot more sense looking at the code.
null, we want to, and then put it the copy up for us. So I hope that this was.
What is the intuition behind this, though? If that makes sense. I'm gonna ask chat what they do. Was it 10? 01? Sorry, I'm just practicing on typing because I think I've been lacking low key. Each original mode has 2 references. Next. Okay. Makes sense. Damn, that's really smart. so I've never done this one. We're given two non-empty linked lists representing two non-negative integers. Reverse order and each of their nodes consisting. Add the two and return the sum. Don't get it. Oh, 3, 4, 2, and 5, 6, 4. I guess we can start by reversing it and then adding it to array and then joining it and then casting it. Jeez. So got a temp, then cur dot equals pre, then pre equals cur, and then cur equals temp. Breathe, and then actually I'm just gonna go ahead and equals list 2, pre equals none, wow. Oh shit, let's just say wow cur. What? Okay, so they're both reversed. I look, you could have just reversed the array, right? I mean, I don't know if using the array is valid. This shit gotta be so inefficient. Oh, that's what it takes in. Oops. Shit is stupid. This definitely cannot be right, man. Dog, I have to return it backwards too. Oh my god. Like, I definitely could do it, but there's just really a smarter way. I'm not doing this shit. Could just mod it and stuff, but like this shit is just definitely not right. I don't know. Is there a faster way to do this?
Hey guys, I'm still unemployed. Hey guys, I'm still unemployed, so let's solve another LeetCode problem today. LeetCode 2, add two numbers together. So just like the problem says, all we're really doing is adding two numbers together, right? So like this example, 342, 465, add them together, right? That's 807. Well, you probably remember from elementary school how to add two numbers together, right? So that's the number one thing to know about this problem, right? So we're adding 342 and 465. So do you remember how to add two numbers together from elementary school? You probably do, but you might think you don't. So let's just look at this, right? 2 plus 5, that's 7. 4 plus 6, that's 10, but that's a 2-digit number, right? So we got to take a carry for that. So we'll put a 0 here, but we know we have a carry, so we're going to have to put that 1 over here, right? So now we have 1 plus 3 plus 4. That's 8. So we just did it, right? That was the result, 807. So you do probably remember how to add two numbers together. That's really the main part of this problem. Now, the second thing to recognize, though, of this problem is that there's a lot of edge cases. That's kind of why there's a lot of dislikes in this problem. You can tell over here. But so there's going to be a lot of edge cases, and we're going to really talk about those edge cases and focus on them. So the first thing they tell us is we're given two non-empty linked lists, right? So these linked lists are representing the integers that we're adding together. So they're non-empty. What does that mean for us?
What the fuck?
How did he just do? Bro, he just started last month. How the fuck did he do this? 182 submissions? What the fuck?
That means if we're adding two numbers, right, like 500 plus something else, right, this second number, it can't be empty. There's always going to be some number here, right? So like 8, for example, something like that. It's never going to be empty. The other thing is that they're non-negative integers. That's really convenient for us because these are linked lists, remember? So having a negative number would kind of be inconvenient, so good thing we don't have to worry about that. The other thing is the digits are stored in reverse order. Now, let's not worry about this too much yet. So for example, we see 342 down here and 465, right? In the linked lists, they're stored in reverse order. So 342 is actually 243. 465 is actually 564. So we'll see later that having them in reverse order actually helps us. And so we want to add these two numbers and return it as a linked list. So for each digit, we're going to have to create a separate node. So we'll keep that in mind. So let's look at a slightly modified example. In the example given, both the numbers had the exact same number of digits, right? So there were 3 digits in each, but we're looking at it slightly different. We added one more digit to one of the numbers because this is kind of a case that you have to consider. So the first thing we're going to do is obvious, right? We're just adding two numbers together. So we're going to go iterate through them, right? So 5 plus 2, that's going to be 7, right? That's our first node. And notice that we're starting at the ones place, right? Because that's how you add numbers. And since the lists, these linked lists are given to us in reverse order, it makes it really easy for us to start at the ones place. That's how you add two numbers together. So they really made it easy for us. So next, we're just going to basically keep doing that, right? So now we're going to get to the next two numbers, add them together. That's going to be 10. So we're going to remember that we have to put a carry. So we'll have a 0 here and we'll make sure to remember we have a carry. So now we're going to do 1 plus 4 plus 3. That's 8. Now we no longer have a carry. So the carry's gone. And now we get to a weird place, right? There's nothing here. So we only have one node, right? So what are we going to say is up here? Well, we can just kind of assume that it's a 0, right? So there's not actually any value, but we'll assume that there's a 0 here. So 0 plus 3, that's going to be 3. And in this case, this is going to be our result. So we just considered one edge case of what if the two linked lists that we're adding together are of different sizes, right? So we kind of know what we can do in that case. Now, there's one last edge case that's kind of tricky. I seem to never remember it when I'm solving this problem, but maybe you'll be able to catch it. So let's say we were adding 7 plus 8 together. Right? Now, when you add it together with addition, right, it's pretty obvious. Let me rewrite it. So we know it's 15, right? So we're going to put a 5 here, but we have a carry. So the carry is going to go here, right? But there's no other number that we're adding here, right? We know we can just put the 1 here. But when you're solving this algorithm, you might forget to do that because with a linked list, 7 plus 8, you add these together, you get a 5, right? That's our result. And you'll put the carry here. You'll say, yeah, there's a carry of 1. But in our algorithm, we have to make sure to remember to put the 1 in our result, right? Even if there aren't any nodes here, right? Like there aren't any input nodes that we're adding it with. So with all of that in mind, let's actually get into the code and it'll probably make even more sense. So the first thing we want to do is we know we're creating a resulting linked list. So I like to just put a dummy node.
I would have low-key never tried to just add it like that.
To not have to deal with any of the edge cases of inserting into a linked list. And our current pointer is going to point at the position that we're going to be inserting a new node or the new digit into. So we're going to iterate through these nodes. Now, how long are we going to be iterating through them? While either of them has a digit. So while L1 or L2 is non-null, we're going to be adding them together. Now, we know one of them could be null, so we're going to get the digits from them. V1 is going to be the digit of list 1. only if L1 is
Wait.
non-null. If L1 is null, though, we're going to...
They didn't give it to us in reverse order, did they? Fuck. They did. So you just want to add the 2 and the 5 to get the 7, 4 and the 6 to get the 0, carry out 3 and the 4 and add the 1. Oh my god! I didn't even... Wow, I didn't even realize. Oh, instruction dead for a sec. Oh my god, that makes sense, because I was reversing it, and I was reversing it back at the end, so why not just add the original ones, right? That would make so much sense. I was so confused. Okay, let's start this. Let's just go ahead and try this. Where's my mouse? What the? What? Oh, it's visual. So yeah, first we create a dummy. And then we do wow. What the? Wow, L1 or L2. No, let's do a carry as well, right? So we need a carry. So initialize it to 0, and then we do while L1 or L2, we do sum or sum. So temp. Temp equals L1 dot val plus L2 dot val plus carry. If temp is greater than equal to 10, then do effort first. First equals temp mod temp mod 10, which should give us the digit, and then oh, so I see why. So he's using a dummy list to add on to, instead of initializing the dummy with a value, because that'd be pretty hard, right? So, oh, okay. So let's just call this add equals a list node with a value of f. Divide by 10. So then you add the list node f. set cur equal dummy, then else carry equals 0. Then dot next equals add equals dot next, and then if carry is not equal to 0, then cur dot next equals node list node with the value of carry, and then we return dummy shit, because this doesn't have a dot next. No, it does. Memory limit exceeded. Fuck. Fuck this. 01. Hey, stop. Oh shit. None type. What? Oh. Wait. Oh, I see. That's why else. What do I do here? Else none? Oh my god, beats 10%. Dang, boy. What am I doing? At least I got it right without having to look at his code. Let's just go ahead and see his solution.
Going to set it to 0, right? Just like we did in our visual example. We're going to do the exact same thing for v2.
Oh, that's how you. Oh my, that's how you do it.
We had a and initially set it to 0, the v1, but now we could potentially have it, right? So that's right. So if our number that we just computed, for example, what if it's 15, right? So that's a 2-digit. We can also, since our value could divided by 10. Also, since our value could be greater than 10, right, like 15, we want only the ones. So that'll give us the ones current dot just computed. So we have to update current. So we're going to set current to the next pointer. We're going to update our list 1 and list 2 pointers if they are non-null. 1 is non-null, else we can leave it as null. Done, we return the list that we just created, but remember
Holy shit, it's exactly what I did, right?
that edge case that we talked about, right? What if we had 8 plus 7? Our loop is going to stop, and we're going to forget about the carry, so continue the loop. 2 are going to carry is going to be 1, right? So we're going to say, we're going to insert a value of 0. List is going to need to annoying. 2, 4, 1.
Oh, I guess you didn't even need that.
Hey everyone, welcome back, and let's write some more. Hey everyone, welcome back. Hey guys, is gonna need to
Wait. Okay, I guess it does. Okay, it's whatever. Okay, that makes sense. That wasn't too bad. I just was not getting the answer at first, so yeah. Makes sense. Finished that, which is good. See if there's a neat code 150 spreadsheet that I can use. This is 75. Damn it. Let me just go ahead and update mine then, because I have it. Might as well just use the original one. See all these. Add two numbers. Okay. That's probably it. That's probably all I'm gonna do today because it's 2. But hopefully tomorrow I'll do a lot more. Hopefully we can finish up the link list by doing these 3, and then maybe start trees a bit. But I'm I'm gaining up on where I left off, which is really good to see since I just started what 14 days, I guess, so 2 weeks ago. And it took me like a month to get to this, and I feel like I'm learning a lot more and like understanding that intuition a lot better, which is really good to see. um I mean, that's what I say so far, but I guess we won't really know unless I like go back and revisit these problems, right? But I feel like I've gotten a way better understanding this time than I did before. And that's it for today. um New Year's is tomorrow. I guess New Year's Eve. But um happy holidays. I hope y'all had an amazing Christmas, and I'll see y'all tomorrow. Peace.